Hello, hi everyone. Welcome to the Student the Brand. So this is your Sir. Today we are going to discuss about motion in a straight line. 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 So what exactly we are going to discuss in this chapter? So first one we will discuss about distance, displacement, speed, velocity, acceleration, and so few more points are there. And equation motion. So once again we will recall entire chapter, means we will discuss entire topics. So like all topics in one place, in one video. So that's the reason we'll discuss all the topics once again. Distance, displacement. Okay, shall we go it? Shall we start? La 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 la. Na na ni na na ni na 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 ni na 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 na. Further correction we are using concave lens, hypermetropia, for a distance we can see, near distance we can see. Hypermetropia, further correction we are using convex lens, hypermetropia, convex lens, convex lensa, convex lensa, hypermetropia, hypermetropia, convex lensa, convex lensa, convex lensa. Cartesian, sign a convention, Cartesian, sign a convention, all a distance measured from the distance positive along the incident is distance negative, opposite to incident is distance positive, above the principal axis distance get to below the principal axis, below the principal axis. So come on everybody, welcome to the class. Now we are discussing. Okay, so motion in a straight line. Motion in a straight line we are going to discuss in this topic. So in this video, especially, so right from starting we'll discuss. Right from starting we'll discuss. Okay. So we can say motion in a straight line. Motion in a straight line. Motion in a straight line. So grade 10, grade 11, not 12, not 10, grade 11. Okay, so NEET JE students, NEET student and MSET students can join to the class. JE, NEET, MSET students can join to the class. Okay, and those are studying grade 11 also can join. Okay, now distance. So before learning distance, we must find out the path. The path is nothing but the length of the successive point, the line joining of successive points from A to B. From A to B, there are many points are there. The line joining of successive points is called path. So distance is nothing but the total length covered by an object. The total length covered by an object is called distance. The total length covered by an object is called distance. All points we'll discuss once again. So in the previous video, you can see motion in a straight line. Everything is there. So once again, we will discuss all the points in one video. So okay. So one video. Hi sir, how are you? Hi sir. How are you sir? I am fine sir. I am doing good. So distance is nothing but from point A to point B. From point A to point B. So there are many paths. You are doing good job. Thank you sir. Thank you so much. I am doing my level best sir. So thank you for your comment. So I am considering here. So from A to B, we can go in any direction. So we can go like this. So we can go like this. We can go like this. We can go like this. We can go in this way. We can go in this way. We can go any way. Okay. So whatever path you followed. So the length of the path, the total length of the path covered by an object, the total length of the path covered by an object is called the total length of the path covered by an object is called distance. The total length of the path covered by an object is called distance. Okay, so it's called distance. I am considering is called distance. So we can take from A to B, any direction, any path we can take. The total length covered by an object is called distance. So next one, displacement. Displacement is that means but the shortest path from initial point to final point. The shortest path from initial point to final point is called displacement. The shortest path from point A to point B, I'm considering, as I said in the previous case. So you can take any way. So any path we can take, any direction we can go. But the shortest path, so the shortest path from initial to final, the shortest path from initial to final is called displacement. The shortest path from initial point to final point is called displacement. The shortest path from initial point to final point is called displacement. So here we can observe, so I'm considering the shortest path from initial point to final point. Okay, so that is called displacement. That is called displacement. That is called displacement. So second one is I'm taking displacement. So I'm considering the displacement. So distance is a scalar quantity. Displacement is a vector quantity. Distance is a scalar quantity. Displacement is a vector quantity. So why we are taking vector quantity? Because so in displacement we have direction. So magnitude as well as direction. So in scalar, so the quantity which have only magnitude, is called scalar. The quantity which have both magnitude and direction, so is called vector. So here I am considering first of all physical quantity. We are considering physical quantity. So next one is scalar, and next one is vector. So the quantity which can be measurable, is called physical quantity. The quantity which can be measurable is called physical quantity. The quantity which can be measurable is called physical quantity. So example, mass, density, volume, speed, velocity, acceleration, and anything we can take. So that is a physical quantity. So scalar is nothing but, particularly if you are talking about scalar is nothing but the quantity which have only magnitude. The quantity which has only magnitude is called scalar. The quantity which have both magnitude and direction. So the quantity which have both magnitude and direction, that is called vector. So the physical quantity which have only magnitude, that is called scalar. The physical quantity which has only magnitude, only if you are taking magnitude, that is called scalar. The physical quantity which have both magnitude and direction, that is called vector. So a scalar example, mass, density. So scalar example we can take for scalar, example of scalar is mass, density, and volume. Okay. So coming to the vector example, velocity, momentum, and acceleration. Okay, so acceleration, this all we can take for the vector. So scalar is only mass, density, like this. So the quantity which have only magnitude, that is called scalar. The physical quantity which have both magnitude and vector is called magnitude and direction. The physical quantity which have both magnitude and direction is called vector. The physical quantity it has only magnitude is scalar. Both magnitude and direction is called vector. A vector. So next one we are going to the next one. So next one we are going to the next point is, so speed we'll discuss speed. So speed we are going to, next point is speed. So third point is speed. Speed is nothing but distance by time taken. Speed is nothing but distance covered by an object per unit time. Distance covered by an object per unit time is called speed. Distance covered by an object per unit time is called speed. And next one, fourth one, velocity. If you are considering displacement per unit time. Displacement per unit time is called velocity. Speed is a scalar quantity. So speed is a scalar quantity. Again, here we need to discuss about speed is a scalar quantity. Velocity is a vector quantity. Speed is a scalar quantity. Velocity is a vector quantity. So here still vector, displacement, acceleration, momentum. Okay, so like so many we can take centripetal force, centrifugal centripetal force, centrifugal force, like that. So many we can take for a vector example. Okay, so now you are considering one more. Okay, so this is about speed and velocity. Coming to the fifth one, acceleration. So we are talking about acceleration. Acceleration is nothing but change in velocity by time taken. Acceleration is nothing but change in velocity by time taken. Change in velocity by time taken. So time we are considering change in velocity by time taken is called acceleration. Acceleration is a vector quantity. Vector quantity. Okay, so this is about distance, displacement, speed, velocity, acceleration. So here speed, if you are taking speed, you are considering. So here uniform speed, equal distance covered in equal interval of time. So the body covers equal distance in equal interval of time. SI unit of speed is meter per second. Very good, excellent, Mandip. Okay, so distance, sorry, speed I am taking. Speed here, uniform speed. Uniform speed is nothing but, so object covers equal distance in equal interval of time. Object covers equal distance in equal interval of time. That is called uniform speed. Non-uniform speed, object covers unequal distance in equal interval of time. Unequal distance in equal interval of time. Unequal distance in equal interval of time is called non-uniform speed. Is called non-uniform speed. Coming to the velocity, uniform velocity, non-uniform velocity, instantaneous speed and instantaneous velocity also there. Instantaneous speed means the speed at particular instant. So you can see, suddenly if you are standing here, so suddenly the object goes like this. The object goes with a very high speed. So at that particular instant, what is the speed of an object? That is called, what is the speed of an object at particular instant? What is speed of an object is called instantaneous speed. Even a velocity also at particular instant, what is the velocity of an object is called instantaneous velocity. Even coming to the acceleration also. So acceleration is nothing but change in velocity by time taken. So v minus u by t. So final minus initial velocity by time taken. That is nothing but acceleration. Acceleration is a vector quantity. Velocity is nothing but displacement by time taken. Speed equal to distance by time taken. Okay, so this is about distance, displacement, speed, velocity, acceleration. So now we will discuss about difference between speed and velocity. I will discuss. Difference between speed and velocity will discuss. Then, so we can see now difference between speed and velocity. So speed I am considering one side, speed here velocity. So now first point is speed equal to distance by time taken. Velocity is nothing but displacement by time taken. Only direction it changes. So displacement by time taken. So here speed is SI unit is meter per second. SI unit, and second one is here first one, right? For this one it is first one. For this one it is first one. This is the first one, and coming to the second one, meter per second. SI unit. So dimensions, as already said, dimension formula is very important for any so any physical quantity, dimension formula is very important. Here m power 0, L power 1, T power minus 1 dimension formula. Either we can take L power 1, T power minus 1 we can consider. Dimension formula speed. Here also same dimension formula, m power 0, L power 1, T power minus 1. So R, we can take simply L power 1, T power minus 1, because here you can observe why m power 0, L power 0, T power 0, K power 0, anything if you take. So m power 0, L power 0, T power 0, K power 0, X power 0, anything if you take, that is equal to power. If it is 0, then we can take so savage high. So then we can take so one we are considering, okay. So next one, anyway, if you are taking L power 1, M power 1, T power 1, so that value only will be, so it's not equal, it is not equal, so it's not equal. Any letters if you are taking power 1 means let it be, so it will be same. Okay, so this is about difference between speed and velocity. And next one here, one more thing. Speed is a scalar quantity. Speed is a scalar quantity. So here I'm considering fourth one. Speed is a scalar quantity. And speed is a scalar. Coming to the vector. Velocity is a vector quantity. Velocity is a vector quantity. Okay. So next one. Anything else? And here, so it's when it will be one more question. One question I will ask. So one question I will ask. In which case, speed and velocity both are equal. In which case, speed and velocity. So what is your doubt? So in which case speed and velocity both are equal? Only in the straight line condition. Only in the straight line condition only speed and velocity both are equal. So speed and velocity both are equal. Only in the straight line condition. Remaining all conditions. If you are taking so straight line condition, so from here to here, so speed and velocity, speed equal to velocity. So magnitude, if you are taking magnitude wise also, so from A to B in straight line condition only, only in straight line condition, speed and velocity both are equal. So so straight line means so one dimensional motion. So curve means 2-dimensional, 3-dimensional also we can consider according to the position of the object. So with represent of x-axis, y-axis and z-axis we can take. So other than a straight line. So here I am considering the speed. Yes, other than the straight line we can take curve. So here. So speed equal to distance by time taken, velocity equal to displacement by time taken. And here we can consider speed equal to SI unit is meter per second, velocity equal to meter per second SI unit. And here I am considering what is that? So here speed equal to m power 0, L power 1, T power minus 1 or L power 1, T power minus 1. Here also same thing, but here we can observe one thing. Okay. So speed is a scalar quantity, velocity is a vector quantity, speed is a scalar quantity, velocity is a vector quantity. So one more condition. So even though displacement is 0, speed cannot be, distance cannot be 0. Even displacement is 0, but speed cannot be. So I'm taking, first point is distance. So distance and displacement. Second one is displacement. So if displacement will become 0, but the speed does not become 0 if the body moves from one point to another point. So if it is moves from one point to another point, definitely maybe a displacement 0. Without displacement, so distance will be there. So in which condition? What are the examples we can take? So we can take curvilinear. So we can take in a curvilinear motion. You can take curve. So we can take the circle. We can take circle. If you are considering here. So I'm considering here. So if you are taking, so the object is in a moving in a curvilinear motion. That is nothing but so in a circular motion. So if the body starts from A and reaches to same point, then so displacement becomes 0. But distance will be there. So distance is 2 pi r. Okay. So and one more condition. So a body is travel. So half of the circle. If you are taking half of the circle, what is the distance and displacement? Half of the circle. If you are taking like this, okay. So a body started from here and reaching to the point B. In this case, displacement is So what is the displacement here? So if you are taking the radius r, this is also r. So radius is displacement is 2 pi r. Displacement is 2r. So here we are considering distance is displacement. I am talking about displacement. Displacement is 2r. Displacement. Displacement is 2r. Displacement is 2r because L plus r plus r from here to here we are taking. Distance is pi r. Distance is pi r. Okay. Distance is pi r. Right. So if you are taking again half you are taking. So half of this one. Half of this one again you are considering. In this half if you take. So what is the distance and displacement? Again if you are half you are considering here. In this case, what is the distance and displacement? Again, can you tell? Distance, displacement and distance. Displacement and distance. Displacement and distance. So in this case, displacement is from shortest path from initial point to final point. So if you are taking R, so this is R and this is R. So this one is R, this is one. R anyway, the angle between these two are 90 degrees. So if you are considering here, okay. So anyway, this angle if you are taking, so from here to here, the displacement shortest path from A to B, if you are taking root over r square plus r square, that is nothing but 2r square. Then you will get root 2r. So the displacement is displacement is root 2r. Distance is pi r by 2. Distance is pi r by 2. Okay. So that's enough. So that is about Ramalakshmi. Hi. Welcome to the class. So now you joined starting only. Very good. So that is enough. So like so velocity, speed and velocity difference. Velocity is a vector quantity. Okay, coming to the acceleration. Acceleration is equal to change in velocity by time taken. Acceleration equal to change in velocity by time taken. So that is about we are talking. Next one. So we'll go to the one example. I will explain with one. We'll do one problem. So with one example, we'll find out speed and velocity. Distance and displacement. Anyway, after that we'll discuss about speed and velocity. So first point is so body travel 10 meters north, 10 centimeter, 10 centimeter or millimeters we can take. So we'll go for a centimeter. Okay. So 10 centimeter north and 10 centimeter again east, 10 centimeter, again 10 centimeter north and 10 centimeter east. So what is the distance and displacement? In this case, what is the distance? Distance first point and coming to the displacement. So how we can find out distance and displacement? Can anybody say? So I will give that. So you can take the so north, south, east and west. So now you can see 10 centimeters towards north. So from point here, I am considering. So okay, we'll take length one because so I am considering here 10 centimeter north, again 10 centimeter east, again 10 centimeter north, again 10 centimeter east. So can we find out what is the distance and displacement in this case? So first point is so simple. So distance means directly you can add everything. So 10 plus 10 plus 10 plus 10, 40 centimeter. But displacement is different. The shortest path I said now. So from here to here, we need to find out this one. So I am considering here. So A to B. So this is A to B. I am taking A to B. So this is root over 10 square plus 10 square. Okay, here also here 10. So root over 10 square plus 10 square. So then we'll get how much? 200. 10 root 2. So this is 10 root 2 because 100. So root over 100 plus 100. So that we are taking 200. That we are considering 2 into 100 root over 100 root is 10. So 10 root 2. So 10 root 2 here also 10 root 2. So then 10 plus 10. So 20 root 2. So total is 20 root 2. 20 root 2. So displacement is 20 root 2. 20 root 2. So in this case, like that we can find out. Like this we can find out. Observe, understand. So distance and displacement. So finding compulsory. Distance means simple word, simple term. You must add everything. Okay, you must add all the distances. So 10 plus 10 plus 10 plus 10. So total how much? Total how much? 40. Total how much we are considering? Total is 40 centimeter. 40 centimeter. Displacement, coming to the displacement is, so you have to take right angle triangle. You have to take right angle triangle. So this is so 10 square plus 10 square. So hypotenuse side square plus side square root over 10 square plus 10 square we are considering. Here if you are taking 10 square plus 10 square. So this is about so what is this one? What is this one? Displacement. What is this one? Displacement only, right? 10 root 2 plus 10 root 2. So total 20 root 2. I hope it is very clear to you all. Okay, next one. If you are going to the next point. So if the body, so already if you are taking the circular motion completed. Circular, so if the body moving in a circular path, so what is the distance and displacement? Even this example also we can take it. This example also we can consider. And one more example. So that is about uniform speed. If the body covers uniform speed. Normally speed formula is, what is speed formula? Distance by, what is speed formula? Distance by time taken. Speed formula is distance by time taken. So speed equal to distance by time taken. First point. So coming to the uniform speed. So suppose one example I am considering here. So if the body is half of the distance from A to B, I am taking A to B. So half of the distance with the speed v1 and the next of the speed with speed v2. So anyway time t1 and t2. So what is the average speed? We have to find out average speed. So average speed if you are finding. So normal average speed formula is so average speed equal to total distance by total time taken. Average speed formula is total distance by total time taken. Total time. So now average speed if you are considering, so that is nothing but, so equal distance I am considering. So this distance. So plus yes I am considering. Okay, half of the distance. So half of the distance with v1, half of the distance with v2. Okay, so total distance s plus s. Suppose if you are taking to s or s by 2 also we are considering, right? So total distance if you are taking same distance, or we can take this one. Okay, total distance by total time taken. Okay, by t1 plus t2, or if you are taking this total distance s, if you are taking this is s by 2 and this is s by 2, that also fine. This is s by 2 and s by 2. If you are taking half of total distance is s, so this is s by 2 and s by 2. That also fine if you are taking s by 2 and s by 2. So 1 by 2 common, you are common. So you are taking s, or we can take s common also fine. Okay. So s 1 s will get. So half s by 2 how much will get? Yes only, right? Yes only. So now we can take T1 equal T1 plus T2. That is average speed formula. So average speed formula in that. So if you are taking the form of, if they give only velocity, so in the place of velocity also we can replace. According to the data, according to the given data, we can use the formula. Okay. So next one. So if the body, so one more case. So this is the A to B. One more case. So this is total distance is S. First it is traveled with the velocity v1. Again it is returns to with velocity v2. So with the speed I'm taking with the speed. So first, so same distance. First distance is v1. Second distance is v2. So average speed equal to total distance by total time taken. I'm taking, right. So here from A to B. So this is the S. Okay. So first distance. So first A to B. So the body traveled with v1. So next. So from B to A, so the body traveled with the V2. Then average speed equal to as I said total time taken. Total distance by total time if you are taking. So total distance how much? S plus S. So this is S and S. So total distance S. Time equal to, so anyway time is different, V1 and V2. So the speeds are different, automatically time also will be different. So T1 plus T2, T1 plus T2. Normally from this V1 equal to S by T1. So V2 equal to S by T2. S by T2 because same distance. Now T1 equal to what is the formula? S by V1. So from T2 equal to T2, from this one T2 equal to S by V2. So substitute the values, average speed equal to anyway this is 2S by T1 equal to how much? T1 equal to how much? S by V1. T2 equal to how much? S by V2. Now we can take S common here. So 2 by here also S we can take common. So here we can take S common. 1 by V1 plus 1 by V2. 1 by V2. We will get cancel. SS get cancelled. Okay. So can we cancel it? Now if you are taking, so 2 into, so you can take LCM. So V1, so V2 plus V1 by V1 plus V1 into V2. If you are taking numerator 2V1 V2 by V1 plus V2. So average speed equal to, if you are considering average speed. Okay. So average speed if you are taking, so V average equal to 2V1 V2 by V1 plus V2. So this is the formula. So if the body, so total distance A to B is S. So return journey, distance is same. If the distance is same, so in one direction, so from A to B it is moving with velocity V1, it's with speed V1 and B to A with speed V2. So if two different speed, automatically time also changes. So time also changes. Okay, then that's the reason V1 equal to, so same distance S by T, total distance by time taken. So that is T1 equal to S by V1, V2 equal to S by T2, T2 equal to S by V2. So average speed equal to total distance by total time taken. Total distance means from total journey from A to B. From A to B again B to A. So total distance S plus S. So S plus S by T1 plus T2. So if they give only speed, in the problem, if they give only speeds, so they don't give any time and distance. If they give only speed, so we can use this formula. Average speed formula is V average equal to 2V1 V2 by V1 plus V2. Okay, so that's enough. That is about average speed. So next we'll go to the one more. Okay. Next one, so we are going to the equations of motion. So that is only speed when now the values are given. So we can find out. Okay, so now we are going to the next one. So equations of motion. So now we'll discuss about equations of motion. Very, very important. This are equations of motion. I will explain in two ways. Equations of motion by graphical method. I'll explain. Graphical method. Okay, so very important. So observe carefully, listen carefully. So graphical method will discuss graphical method, equation motion by graphical method, and integration method also will discuss both the cases. So now you are considering now we are considering one example. I will tell one example. Suppose the object is here. The object is here. So from point A. So it's starting with initial velocity u and reaching to the final velocity v. So suppose object A. So object is at A. So starting with initial velocity u and reaching to the final position v. Final position v. Final position v. So here, so it travels certain distance with the time t. So it is moving with uniform acceleration. Uniform acceleration. So A I am considering. So that is pseudo force. That is a pseudo force. Actually, centrifugal force is a pseudo force because when the body is moving a circular path, okay, so the body which is acting towards the center, the force which is acting towards the center. So by balancing that one, centrifugal force will act. Okay, so when if you leave that, what will happen? Suddenly, if you reduce the speed, what will happen? So we are moving towards, we will fall towards the center of the, okay, towards the center to balance that one. So one force will act, that is away from it. If you are taking, so if you leave the, you rotate the thread, rotate the to stone tying at the end of the thread and rotate and leave like that. Okay, if you reduce the speed, automatically it will come and hit us. If you increase the speed and leave, so directly at the along the tangent it will move, along the tangent direction it will move. So even here also, the person who is rotating in a like a bell manner, like in circus you can see. So by a bike stunter, so he will move like this. So if you reduce the speed, he will fall towards the center. So if you increase the speed, he will move away from the center. So centrifugal force is a pseudo force. Okay, pseudo force acting or balancing the centripetal force. Okay, so here I'm considering point A and point B. So object is at position A, and same object reached to point B. So initial velocity u and final velocity v. Initial velocity u and final velocity v. Okay, so okay, we'll discuss that one. So because we are discussing this topic, right? I will discuss. So we our name better. Okay. So we'll discuss that one. Okay, sequence you are asking, right? That we'll discuss later. First, we'll go to the past. No, we'll go to the sequence. Now we have taken the object is at A, so initial velocity u, and the object is B at B, so final velocity. So it's moving with the uniform acceleration. So it travels at distances and within a time taken t. Within time taken t. Okay now, so I hope it is very clear. Now we can see, now we are considering. So the same situation, we'll draw, we'll write, we'll represent on the graph. How to represent the graph? So now I am considering here. I am taking like this. Okay. So velocity on y-axis, time on x-axis we are considering. Velocity on y-axis, time on x-axis. Okay. Velocity on y-axis, time on x-axis. So the object is starting from point A. And reaching to the point B. Object is starting from point A with initial velocity. Here, the velocity of the object from here is from 0 to origin to A is initial velocity u. So from here, so if you are taking this one, okay. So okay, Karthik Reddy. Now you are considering. So here I am taking. So here C, D and E done. So this is the initial velocity and here I am taking this is the final velocity. This up to here. Again I am saying until here initial velocity. This is the initial velocity only. Up to here initial velocity. I am taking this initial velocity U, and from 0 to point B is final velocity. Okay, so be careful. So with respect to velocity time graph, velocity time graph. Okay, so now I am considering BC equal to BD plus DC, BD plus or DC or CD we can take. So we can consider BC equal to BD plus DC. So let it be DC, okay, or be DC or CD also fine. So BC we know final velocity, and BD we have to find out, plus DC equal to DC or CD or OA. So here we have to note down here, you can see OA equal to CD equal to OA equal to CD equal to U, or so OC equal to AD equal to T. Okay now. So once again here OA equal to initial velocity, that is nothing but CD or DC. Okay, CD or DC, or OC equal to AD. That is nothing but T. Okay now. So now you can see. Now we are going to the next one. So DC equal to initial velocity. So BD equal to V minus U. Now you can consider slope of AB. Slope of AB is nothing but slope of AB if you are taking, okay, final velocity minus initial velocity, that is the change in velocity by time taken, that is nothing but BD by AD. So slope of AB I am taking AB. Okay, so BD is nothing but we don't know, so BD equal to AD we know, right? AD is nothing but what is this component, this until here it is T. So now you are considering, so slope of AD is nothing but acceleration equal to BD by AD equal to T. So from this BD equal to A into T. So A into T. Substitute in the place of BD. So V minus U equal to A into T. From this V equal to U plus AT. So that is the first. Okay, so this is the equation 1. It's the equation 1. Equation motion. First equation, V equal to U plus AT. So keep this one aside. So very important. We will use this one later. So V equal to U plus AT. So V equal to U plus AT. Alright. So now we'll go to the next one. So position and time graph. Next graph is position and time graph. With the help of position and time graph, what will happen? We'll see. Position and time graph. So position and time graph we'll discuss. Position and time graph. Okay, position and time graph we'll discuss. Now you can see here. So this is the areas. This area under the this rectangle and square, if you are taking displacement will get. So that is nothing but distance. So total distance you have want to find out area under this one. Area is nothing but this is the rectangle format. Rectangle format is nothing but OC into AD we can take, or OA into AD. That is your choice. So you can take OC into CD. I am taking. So it is easy. OC into CD plus half into this is the triangle half into base into height. Base is nothing but AD. Height is nothing but BD. What is the base? AD. Okay, so AD is the base. I am taking half into half into base is nothing but AD, base is nothing but AD, and height is nothing but BD, and height is nothing but BD. So in the previous case, we found BD equal to A into T. So this also very important. Now we are considering S equal to OC is nothing but T, and CD is nothing but CD or OA, CD or OA is nothing, initial velocity plus half into AD is how much? AD is T, and BD equal to A into T, then you will get S equal to UT plus half AT square. S equal to UT plus half AT square. This is the second equation. This is the second equation. This is the second equation. So equation number 1 is V equal to U plus AT. So next equation is S equal to UT plus half AT square. S equal to UT plus half AT square. Coming to the third equation, once again you can see, so area, if you are taking this area, that is nothing but OC into CD, that is OC equal to T, CD equal to initial velocity, and half into base into height. Half into base is nothing but AD, AD is nothing but T, and BD is nothing but AT we already found. So S equal to UT plus half AT square. This is the second equation of motion. Coming to the third equation of motion, position and velocity graph. Position and velocity graph. In this case, so it looks like a trapezium. So trapezium, position and time graph. Your position and velocity graph you will take. Velocity graph in this case. So it is a trapezium. So this total we are considering total distance if you are taking. So parallel sides, sum of the parallel sides OA plus BC, OA plus BC into base. Base is nothing but OC we can take. So this is the OC only, because the entire trapezium will take by 2. So by 2. So now we are taking OA equal to how much? OA equal to initial velocity. BC equal to how much? OA equal to initial velocity. BC equal to final velocity. BC equal to final velocity. What is the BC? BC equal to final velocity. What is the BC? Final velocity. What is the BC? Final velocity. What is the BC? Final velocity. So final velocity I am taking. And OC is nothing but how much? OC is equal to what is the OC? What is the value of OC? OC equal to T. T by 2. But here from this equation, from first equation of motion, from this what is time? From this how can we take time? So from this we can take, shall I take T equal to V minus U by A? Shall I take? So is there any difference? No difference, I hope. So T equal to, so we can take from first equation of motion, T equal to V minus U by A. V minus U by A. Substitute in this T value. Substitute now. S equal to U plus V into, so V minus U by A by 2. Then S equal to, so if this is here, we can take A plus B. So A plus B into A minus B. A plus B into A minus B, that is A square minus B square. So A plus B into A minus B formula is A plus B into A minus B formula is A square plus A square minus B square. A plus B into A minus B equal to A square minus B square. Now we can take V square minus U square by 2A. So from this we'll get V square minus U square equal to 2AS. Understood? So this is about equation of motion from graphical method. This is about so equation of motion from graphical method. This is the equation of motion from graphical method. Now we are going to the one more that is so same equation of motion, by using same equation of motion, so we can solve with the help of integration method. With the help of integration, I'll explain equation of motion, so you can see frequency. So normally what is same, I already said in the starting. At the object is moving. Na 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 ni na na la la li la 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 li la 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 li la 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 na ni na na ni na na ni na 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 ni na na ni na 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 ni na na ni na 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 na. Okay, next we are going to the same equation of motion by using of it is one of the teaching aid, so I'm discussing this one. Hi. So now we can so equation of motion by integration method. So now we'll see. Normally, if you are taking already in the previous case, object is initial velocity u, final velocity v. So time t and distance covered is s. Distance covered is s. I'm taking. Now same thing in the form of integration. Acceleration equal to. So what is that one? So dv by dt, dy by dt. So from this one, so dv equal to a into. So if you take integration, so initial to final, so dv equal to, so integration, so time anyway, so the body, if you are taking this object, initial velocity 0 only, so final velocity certain time t, so time and after certain time only, right, after certain time only the body moves until certain distance. Initial velocity u, final velocity distance s, and acceleration here. So with that case, I am taking acceleration equal to dv by dt, that is nothing but dv equal to cross multiply, then you will get a into dt integral. So limits initial velocity and final velocity dv, then a into dt. So integration, so limits 0 to t. Now, so we are taking v into, so limits u into u to v. And here also a into t we are taking. A we are taking common with respect to time we are considering. So 0 to t. Now v minus u, you have to substitute. This values you have to substitute into a into anyway t minus 0. That is nothing but v minus u equal to a into t. V equal to u plus at. So that is the first equation of motion. Coming to the next equation of motion. So here we are taking the same formula, v equal to u plus at. So yeah, velocity if you are taking distance by, so derivation of distance by time taken. So initial velocity plus final velocity, initial velocity plus at. Now ds equal to u plus at into dt. So take integration. So in this case 0 to s anyway. So distance travel 0 to s only, right? Until here, so from here to here. So here is 0 and it is up to reach to point A to point B, distance is s only. So here final point the distance will consider. Here we can't consider, right? That's why 0 to s ds equal to integral 0 to t. So u plus at, okay, dt. Then we are considering, so s 0 to yes, I am considering here initial. So initial with respect to time we are doing 0 to t plus a we are taking common to t square by t. So integral x equal to x power n plus 1 by n plus 1. So with that formula we are considering integral x dx equal to integral x dx equal to x power n plus 1 by n plus 1. Now, so now we are considering S equal to ut plus, so here we are taking anyway 0 to t only, right? 0 to t only. So t square will get at square by 2. That is nothing but S equal to ut plus half at square. Ut plus half at square. So that is second equation of motion. Second equation of motion. Understood? Next one, coming to the third equation of motion. Third equation of motion. So I'll discuss third equation of motion. Now you can see. So square on both sides. This one square on both sides. So v square. This one square on both sides. V square equal to u plus at whole square. Then v square equal to u square plus at whole square plus 2uat. So now v square equal to, so from this we can take common u square common, 2a common from this. If you are taking 2a common ut plus half at square, because 2 is not here, right? So we are taking here 2 is there, but here 2 is not there. A is there. Remaining a is there, t square is there. So I am taking, so ut plus half at square, what is the formula? Ut plus half at square is S. Ut plus half at square is S. Yes or no? Ut plus half at square is S. So ut plus half at square is S. So v square equal to u square plus 2as. So now v square minus u square equal to 2as. This is the equation, third equation. So this is about equation of motion. I hope it is very clear. So this is a class. Few problems, actually problems. So it's a taking time problem. So we have to write and solve it. So that is the reason we are recalling the concept. Already I did videos on this one. So today we are going to discuss. So today we discussed enter all the topics once. Okay. So it's like a revision. It's like a revision. So if you have any doubts, you can ask. So if you need any classes regarding the physics or remaining subjects also, if you want, you can contact this number 98498-12804. 98498-12804. This is the number. So you can, for not only physics, you can go for remaining subject, maths, so chemistry. So now 6 to 12, and JEE NEET students also, you can contact me for subjects, remaining subject. So this is our Siva sir from Student the Brand. If you like this video, do like, share and subscribe to Student the Brand. If you like this content, you can inform your friends, ask them to join and learn the physics. So that's enough for today class. So we'll discuss same thing. So classes timings 11 a.m., 3 p.m., 6 p.m. and 9 p.m. Again 9 o'clock we'll be having class. So come and join to the class. So we'll discuss. So this is your Siva sir from Student the Brand. So signing off. Thank you.